In today's video, we're going to determine equations from tables. So we've been in the last few days exploring the relationships and talking about the connections between equations and tables and graphs and words. Here we're going to look deeper at the connections between tables and come up with equations. All right. So before we do that, though, I want to remind us of a concept. So the last few days we've been talking about slope. We did the slope formula, y2 minus y1 over x2 minus x1. We did rise over run. We also said it's delta y over delta x. It all means the same thing. Okay, the delta y is the change in y, the rise, the y2 minus y1, and the delta x is the change in x, the x2 minus x1, the run. Okay, but earlier we discovered that the slope and first differences also had a connection, that the first differences told us the slope. So that means the first differences and this delta y over delta x are going to be, there's a connection between those, that they're the same. And that'll be helpful for what we're doing today. So I'm going to fill out a bunch of examples with you here, and then I'm going to ask you to try a few on your own. In this first example, I've decided to make a column for delta y over delta x, but later on you can either just write them on the side or you can just imagine them in your head. So let's just look at this relationship as x is 0, 1, 2, 3, 4, y is 0, 5, 10, 15, 20. Now, we don't have a specific scenario here. We don't know if this is talking about you make $5 an hour or you cost $5 per ride. We don't know that. And it doesn't matter. We're just making the connection between x and y. So let's look at the first difference. So going from 0 to 5, that's a first difference of 5. From 5 to 10, that's a first difference of 5. Remember, you can get these also by subtracting. 15 minus 10 is 5. 20 minus 15 is 5. These first differences all say that it's 5. So right now, if you remember back when we did our scenarios, we said, well, if that's a 5, then the equation is 5x. And you're not wrong. But don't forget that the only way we could use this first difference is if our x's went up by the same amount, and we preferred ones. And that's actually what's happening here. So the delta x does go up by ones. So there is a connection between this 5x and the slope. So remember, slope is delta y over delta x, or rise over run, or change in y over change of x. So if we see that the change in y here is 5, and the change in x is 1, we get the fraction 5 over 1, which is, of course, 5. And so it does work and match up that the equation is right there, and your slope goes right in front of that. And we do have that connection that we saw before. Now I can check this equation to see if it actually represents this table. Choose any value for x and plug it in. So I'm going to choose 2. So 5 times x, 5 times 2 is 10, and it's working. Just because it works once, though, it has to work for everything. So I'm going to try a second one. Let's try 4. 5 times 4 is 20. I think we've got the right equation. Let's move on to the next one. So I don't have the columns for this, but I can still look at it and recognize I can write them on the side. So for example, let's first make sure the x's go up by the same amount. So I can see definitely going from 0 to 1, that's a jump of 1, jump of 1. These are all going up by 1s, even though it starts at a negative. It's getting bigger by 1. Now let's talk about the y's. The y's at 6, and then it goes to 3. Well, that's a first difference of negative 3. Remember, if it's going down, our first difference must be negative. And does it keep going down? Yes, negative 3, negative 3, negative 3. I should tell you all of these ones are linear. So you may remember doing something similar to this where we're checking to see if they were linear or nonlinear. Here they're all going to be linear. That means all the first differences will be the same. So then if I'm predicting then if these go up by 1s, this is going down by 3s, so the equation must be negative 3x. And this could be a situation where every time you ride a ride, you owe $3 and you owe $6 if you're borrowing money from your friend. Okay, so that's a scenario there. And again, we can check and see if this makes sense. Let's try 2. Negative 3 times 2 is negative 6. Let's try the negative 2. Negative 3 times negative 2 would be a positive 6. So I feel pretty good about this. Let's look at the next one. Going up by 1s again. It looks like it's all going up by 1s. Now let's read the y's. 2 to 3 to 4 to 5 to 6. That looks like it's going up by 1s as well. Again, you can check any of these by subtracting. 5 minus the one before is 4, is 1. So I'm going to then predict that my equation is y equals 1x. Let's check. Take a 3. 3 times 1 is whoa, it's not 5. So something's going on here. 4 times 1 is 6. So this equation isn't working. Now the first differences are 1. So what's going on? Well, in this particular example, you're actually starting with a flat rate. So look at this scenario. 0 actually starts at 2. So you're beginning with a flat rate. You're beginning with a number. So for example, maybe it costs $2 to get into the fair and then $1 after that. Okay, so that means this equation has to have an adjustment to it. The 1x isn't good enough. We also have to add 2. And that makes sense. Now, y equals 1x plus 2. Let's test this. Let's try 4 again. Plug in 4. 1 times 4 is 4, plus 2 is 6. So it's working. Now, you might just write this as y equals x plus 2, because if it's 1x, you don't necessarily need to write the 1. So it's curious about this initial value. How come it didn't pop up in the other ones? Let's look back at this one. Let's look at the beginning, the initial value. 0 and 0. So there is an initial value, it's just the initial value is 0. So technically this equation actually has a plus 0 on it, but we don't need to write it. Okay, there's no initial value. It's a direct variation. It starts at 0, and so you don't have to write the plus 0. What about this one? I thought this one looks like it starts at 6. Well, it doesn't start at 6. When we're talking about starting, we're talking about when x equals 0. So we're actually looking for the 0x. That's going to be our initial value, our flat rate. Does it cost anything when the x value is 0? And in this particular case, it doesn't. There may be numbers before it, and that's okay, but you have to find the x equals 0. That's our starting point. So this one is also a plus 0, but I've chosen not to write it. Okay, so that's something now that we're going to have to consider. What is the slope and the first difference, and where does it start? And that starting point isn't necessarily at the beginning of the graph. You just got to find the 0 value. All right, let's move on to the next one. X equals 1, 2, 3, 4. Okay, these are all going up by 1s. How about these? Negative 1 to 1. That's a little harder to see, but going from 1 to 3 is 2, 2, 2. Is it all going up by 2s? Yeah, I think so. Even this one, if you're at negative 1, you go up 2. You go from negative 1 to 0 to 1. Good, that's up 2, up 2, up 2. So the first differences are all 2 over, so the delta y's are 2, the delta x's are 1, so the slope is going to be 2x. But let's not forget about our starting point. In this case, you can see the starting point is up here, so you're going to have to subtract 1. So that means it's going to be 2x minus 1. Let's test it. Let's test it on something like 4. Plug in 4. So 2 times x, 2 times 4 is 8, minus 1 is 7. Let's try it again with 2. 2 times 2 is 4, minus 1 is 3. Even the 0 works. 2 times 0 is 0, minus 1. Okay, so let's try a couple more examples. All right, so I'm back here and I've given you another delta y and delta x, which must be for a reason. Let's start calculating the first difference, going from 3 to, going from 1 to 7, that's a jump of 6. 7 to 13, that's another jump of 6. This is all a jump of 6. This is all a jump of 6. So my first gut is the equation is y equals 6x. But if I think about that 6x, really, wait a second, that's 6 times 2, that's going to get me 12. That's not going to work. 6 times 4 is going to get me 24. What's going on here? Well, the reason is this is not your true first difference, because this x's do not go up by the same amount. These go 0, 2, 4, 6, so they go up by 2's. So how does that change things? Well, let's think about our slope. Our slope is delta y over delta x. So our delta y's are 6's, and our delta x's are 2's. So for every 2, we go up 6. Every 2, we go up 6. Well, 6 over 2 is the same as 3. So that means my equation is actually 3x. And I would get a 3x. Let's not forget about our initial value in this case is plus 1. So we have to be very careful not to just go and look at the first difference. We got to make sure that our x's also go up by the same amount. And if they don't, then we got to calculate the slope. Change in y over change of x, 6 over 2 is 3, and then of course our initial value. Now let's test this. Let's test on 8. 3 times 8 is 24, plus 1 is 25. 3 times 4 is 12, plus 1 is 13. So it's working. Okay, let's try the next one. I already see these x's are very different. Now you see they're negatives, but negative 12, negative 8, negative 4, that's getting warmer, isn't it? 0, 4. So I think these are all going up by 4s. Going up by 4, up by 4. Even though going from a negative to a negative 12 to a negative 8, that's still going up by 4. And what does the y do? Oh, it's really hard to see this. Let's try a number down here. Negative 3 to 5. So if I subtract them, that's 5 minus minus 3. Well, minus minus is getting colder. If you take away negatives, you're getting warmer. So that means this is an 8. And I can imagine the number line. You're at negative 3. You can go negative 2, negative 1, 0, 1, 2, 3, 4, 5. And that's 8 spots. Is that true from each of these? Am I going up by 8s? I think so. Here I am at negative 19. And if I get 8 warmer, I'm at negative 11. So yes, it's going up by 8s. So let's think about this one. The rise is 8, and the run is 4. So delta y over delta x is 8 over 4. So the equation is 2. So the slope of this is 2. Let's not forget about our initial value. It's negative 3. So I think then the equation is 2x minus 3. Let's test that. Test it on 4. 2 times 4 is 8. Subtract 3 is 5. Okay, let's move on to the next one. Okay, we're back to the delta x's going up by 1, so that's good. So we don't have to worry about any division. But this is interesting, going from 9 to 9 to 9 to 9 to 9. That is all the first difference of 0. Okay, let's try find our starting point is right here. So 0, 9. So if the slope is apparently 0, and the initial value, the starting point is 9, so we could write 0x plus 9. Now, technically, you don't have to write the 0x because 0 times x is 0. So most likely, you'll just see it like this, y equals 9. So let's think about that. Do you remember from our slope investigations what a slope of 0 looks like? Slope of 0 is a horizontal line. It should go like this. So let's see what's going on with this equation. So if I've got a really rough graph here and I went up to 9 and I plotted these points, I started plotting them, all these points, if it's 1, 9, 2, 9, 3, 9, negative 1, 9, it doesn't matter what you put in, you're getting a 9, and you do that an infinite amount of times, you're going to get this horizontal line at 9. And so it does actually make sense. All right, let's move on to the last one here. Let's see here, our initial value is 5, and then what's it doing? Well, this time it looks like it's going from 5 to 4.5. So they're going decimals. That's no big deal. They're getting smaller by 0.5. All right, good. And these are all 1s, so that's good. So the slope then is negative 5, and it starts at a plus 5, or sorry, negative 0.5. And so our equation is negative 0.5x plus 5. All right, so those are a bunch of examples. What I'm going to invite you to do now is go to the Google Doc. You can either do it now or watch the rest of the video, but this is the first half of it. You can go to the Google Doc and try this on your own. So I'm going to go here to the Google Doc. You'll see the answers are there on your own, but I've just left a few of these blank. So for example, here's that one example we did. So you're just going to sub in the numbers to this one goes up by 2s. And I think we remember this one went up by 6s. So the equation is 6 over 2 is 3, so it's 3x. And remember the initial value of plus 1. Okay, so that's what you're going to do. You're going to fill in these down at the bottom. This one, I don't have any spots here, but I can go back and check and see what was my answer for that one. Yeah, it was 2x minus 3. So I'll go back to my Google Doc and say 2x minus 3. So you don't have the luxury of writing out the first differences like I did on the screen before, but you can just maybe do them on a piece of paper or observe. So for example, you see how this one's going 7 to 4, so it's going down 3, down 3, down 3, and you should be able to come up with the equation. And these are going up by ones. Okay, so you can pause your video if you want to just do these questions in the Google Doc, then feel free. Otherwise, we're going to move on to a second part where we're going to do the opposite. I'm going to give you the equation, and you're going to need to come up with the table of values. So here, we're calculating the table of values when you have the equation. All right, so the first example is y equals 3x. So we've learned before that that number right there is the slope, and the slope is 3. Now, we like to write this, if we're thinking about slope, we like to think about it as rise over run. It's 3 over 1. So that means the delta y is 3. So that means this is all 3. And the delta x is 1. So these are all 1. Okay, so now we've got this fraction. Now we can use this to fill out the rest. You'll notice this is 3x plus 0, just like in the one before. So that means it starts at 0. And when I say start, I mean the initial value, when x equals 0. So if x equals 0, this one is a 0. Next, all you need to do is follow the pattern. You know the first difference is a 3. That means the y's are going to go up by 3. So if you're at 0, we're going to go to 3, and then 6, and then 9, and then 12. And so this equation comes up with this table of values. Again, you can always test. 4 times 3 times 4 is 12. Okay, you can get these by just plugging in the values as well, but if you understand the first differences, all you have to do is follow patterns instead of actually having to do the math. Let's try the next one. This is y equals 5x, so that means the slope is 5. So as long as this is going up by 1s, which it is, this is going up by 5s. And there's no initial value, so it starts at 0. Now be careful. The start in here is not at the top of the table of values. The start is when x equals 0. So if x equals 0, then because there's no flat rate, y is equal to 0. And now you can follow the pattern and go up by 5s. So go 5, 10. You can check. Okay, so plug in the 2. 5 times 2 is 10. And if you're going up by 5s, you don't have to worry about plugging in. You can just follow the pattern. If you're going up by 5s, what was it before? Must have been negative 5. And before that must have been negative 10. So going up by 5s. Again, you can check. 5x, 5 times negative 2 is negative 10. Move on to 0.5. So we already saw one with this with 0.5s. Notice the x's all go up by 1s. That means the y's are all going to go up by 0.5. This one's positive. There's no flat rate, and the x equals 0 is up here. So you're going to go up by 0.5. So 0.5, 1, 1.5, 2. Again, any of these will work. You can plug in 3. 0.5 times 3 is 1.5. The last one, I'm not going to put down the first differences of these things. I think I can do it in my head. Let's start. This time, though, it does start at 3. So we're going to have a 3's here. And then it's going to go up by 2's. So if I start at 3 and I go up by 2's, I can just start going up by 2's from 3. So up by 2 is 5, 7, 11, 9, 11. And by following that pattern and understanding this relationship, we can get these numbers really, really quickly. You, of course, can just substitute x equals 4. So take 4 and sub it in here. So 2 times x, or 2 times 4, is 8, plus 3 is 11. But following the pattern works just as quickly. Move down onto another one. Again, I've decided to give you a relationship here. So, but look at the delta x's. So this one goes 0, 2, 4, 6, 8. So that means it's going up by 2's. All right, so I'm tempted to say that the y's are 3's, but the y's are not 3's if the x's don't go up by the same amount. So let's think more about this one. So we know the slope is 3. If we were to write that as a fraction, we would say it's 3 over 1. That would mean the delta x would be 3 if the delta x is 1. But in this case, the delta x is not 1. The delta x is -2. So the question remains, if the delta x is -2 and my slope is 3, what must the delta y be? Well, I've got the fraction 3 over 2. 3 over 2 is the same as the fraction 3 over 1 is same as the fraction 6 over 2. 6 over 2 is the same as 3. So if your delta x's go up by 2 and your slope is 3, that means your delta y's must go up by 6. And each of these must go up by 6. All right, so that's a kind of a tricky one, but good that we had a chance to walk through it. Where does this one begin? Well, the plus 4 tells me the starting point when x equals 0. You plug in 0, 3 times 0 is 0, plus 4. So this case, there's a 4 is where we start. And then we follow the pattern. We don't need to worry about the equation anymore. We follow the pattern. We're going up by 6's according to this table. So if we're at 6, we go up, we're at 4 and we go up 6, we're at 10. Up 6, we're at 16. Up another 6, 22, and 28. You can confirm this works for any of these numbers. Let's try 6. 3 times 6, 18, plus 4 is 22. We've done this right. All right, so that one was a little tricky. That's why I gave you the delta spots to be able to make sure your delta. This only works, your delta y's, your first differences only works when the x's are 1. If not, you might have to make an adjustment. All right, so we'll finish with these last 3 here. These ones, luckily we're back to 1s where the delta x's are 1s. It says 4x minus 1, so we're going to start at a -1. Remember, start doesn't mean the top, it means the 0 value. So here the 0 value is right here. So that's -1. And the slope is 4. And since these are going up by 1s, these are all going to go up by 4s. So we can just follow the pattern. We're at -1, and you go up by 4, that's going to get you to 3. And then if you go up 3 more, that's going to get you to 7. If you go backwards, where were you before if you went up by 4 to get to here? You're at -5. And before that, -9. Again, check our equations and make sure it makes sense. Plug in 2. 4 times 2 is 8. Minus 1 is 7. Even a -1. 4 times -1 is -4. Minus 1 is -5. Okay, let's move on. This one I'm not going to write down my deltas, my delta x's, delta y's. I think I can do this in my head. You see that this has got no starting point. So it's just going to be at 0. So for 0, it's 0. And this is -6. That means the slope is -6. That means it's going down 6. So if I'm at 0 and I go down 6, I'm at -6. Go another down 6, I'm at -12. And if I follow the pattern backwards, if I'm going down 6, that means I must have been at 6 before. And before that, I must have been at 12. Because I'm going down 6, down 6, down 6, down 6. And finally, this last one, y equals -x plus 4. The plus 4 tells me I start at 4 when x is 0. So again, I got to hunt down the 0. You see how sometimes the 0 is on the top, sometimes it's in the middle, doesn't know where it is. Here it's 0. So if x is 0, y is 4. Right? Plug in 0 plus 4 is 4. And the slope on this one, you see -x. Remember, -x means there is a number in front. It's just a 1, a -1. So this means it's going down by 1. So again, if I follow the pattern, 4, down 1 is 3, down 1 is 2, down 1 is 1. And if I work backwards, that means that would have been 5. Test it out, plug in a 3. -3 plus 1 is 1. Or plus 4 is 1. If you put in a -1, what's negative times negative? That's +1 plus 4 is 5. All right. So you're going to go off and then use the equation to complete the table of values in the Google Doc. So I'll go back there onto the second page. The first 8 will be done with you, and then you're going to do the last 8 on your own. Remember, you're just going to go in and plug in the numbers. So you see in this case, remember this is the one we did together, so it starts at 4, So we're going to go 4. And then remember this one, the runs were 2, the delta x's were 2, and this we discovered the delta y's were 6. Remember, this is just coming from our example. I'm just copying it down here. There it is, right? Delta 2's, or those are 2's and 6's. And then it went 4, 10, I went up by 6's. So I would just fill in the table from here. 10, 16, 22, 28. All right, you're going to do that for down here. This last one, remember, this one started at 4 and went down by 1. So down by 1. So 3, 2, 1, and you can go up and 5. So you're just going to be filling in these tables given the equation. So once you've done this second half, you've already completed the first half, you'll have a turn in button. You can turn in those and I can check and see how you did. All right, best of luck. Good job.